In this video, we're going to look at how to solve two-step equations. All right, you have learned how to solve one-step equation, such as 3x equals to 15, where I have multiplication, and we undo multiplication with division, and we divide both sides by the coefficient that is next to the variable, so that we isolate the variable when these guys cancel out, and that leaves you with x is equal to 5. And then you also know how to solve addition and subtraction problems by getting rid of whatever the constant is that's on the side of the equation with the variable. And in this case, it's a -3. And the opposite of a -3 is a +3. And whatever I do to the left side, I have to do to the right. So then when I look at this problem, I have -3 plus +3. These will cancel and leave me with x on this side, and 15 plus 3 is 18. Now, what do you do when you mix both types of problems together? So you take your multiplication and you take your subtraction and you put it all in one problem. How do you tackle this? Well, let's look at the steps on the next page. All right, let's look at the rules for solving a two-step equation. Our goal is going to remain the same as it does for any equation. We are going to isolate the variable. So the first step we're going to do is to use the inverse operation to add or subtract on both sides. And that means let's get rid of the constant. The second step is going to use the inverse operation to either multiply or divide by the same value on each side to get rid of the coefficient. And then because you have an answer or a solution, you can check it. Okay, let's look at a couple of examples. I have -3x plus 1 equals 7. I need to isolate this x, so I need to get rid of this constant and this coefficient. So I'm going to start with the constant first. The opposite of a +1 is a -1. So I'm going to subtract 1 from both sides of the equation. Remember, I need to keep my equation balanced. The 1's cancel out, and I'm left with -3x on the left side of the equation. And then 7 minus 1 is 6. Now, what I have left for an equation is -3x is equal to 6. This is multiplication on this side of the equation. We undo multiplication with division. So I'm going to divide both sides by -3. What happens on this side of the equation is my -3's cancel out and leave me with x, and then I have 6 divided by -3 on the other side. 6 divided by -3 is a -2. So my solution is x is equal to -2. Now, let's look at the next example. 1/2 x minus 9 equal -25. Again, my variable is on the left side. I need to isolate that variable. I need to get rid of the coefficient of 1/2 and the constant, which is a -9. I'm going to start with that constant first. The opposite of a -9 is a +9. So I'm going to add 9 to both sides of my equation. My -9 plus +9 will cancel out and leave me with 1/2 x is equal to -25 plus a +9 would be a -16. All right, now, how do I get rid of that 1/2? Well, the 1/2 is being multiplied by x. To get this to be a coefficient of 1, I need to multiply it by its reciprocal. And the reciprocal of 1/2 is 2/1. And whatever I do to the left side, I have to do to the right. So I'm going to multiply it by 2/1 over here, and I can put 16/1 if you want to make the two fractions. Now on this side of the equation, my 1's will cancel, my 2's will cancel, and I'm left with just an x on this side. And then on the right side, I have -16 times 2, which is -32. All right, let's look at a couple of more examples. In the first one, I have -7x plus 15 equal -6. So I need to isolate my x. So I'm going to look at the constant first, which is a +15. The opposite of +15 is negative 15. So I'm going to subtract 15 from both sides. Positive 15 plus negative 15 will cancel, and I'm left with negative 7x on the left-hand side. Negative 6 plus positive 15 would be negative 21. And now, my last step, I have negative 7 times x. We undo multiplication with division. Whatever I do to the left side, I have to do to the right. So I'm going to divide both sides by negative 7 so that my equation stays balanced. Now, on the left side of the equation, I have a negative 7 divided by a negative 7. These guys are going to cancel out and leave me with an x. And then I have negative 21 divided by negative 7, which is a positive 3. So my solution is x is equal to 3. All right, let's look at the next example. And I know your first thought is going to be, oh no, there's fractions in it. I don't like fractions. I don't know how to do fractions. Well, you can easily do fractions if you follow one simple little trick. If you notice my denominators, they are 4 and 2. I know that 2 goes into 4, and that if I multiply this whole thing by a 4, what's going to happen is this 4 and this 4 will cancel, and 2 will go into 4. So let me show you what I mean. I'm going to essentially distribute this 4 to every term that is in the parentheses. So I'm going to rewrite it as 4 times 3/4 x minus 4 times 2 is equal to 4 times 1/2. And let's put 4 over 1 for that one. And let's do it here too. So now I have some simple little problems that I can go and do. I know that this 4 and this 4 will cancel out. So these will cancel and leave me with 3x. And then I know that 4 times 2 is 8. And then the last one, 4 and 2, I can simplify that ahead of time. 2 goes into itself once and 2 goes into 4 twice. So I have 2. 2 times 1 is 2. And then we have on the bottom 1 times 1, which would be 1, which we don't need to put that there. So now I've made this a much easier problem to solve. No fractions now. I got rid of them by distributing that 4. So let's start with the negative 8. The opposite of negative 8 is positive 8. So I add 8 to both sides. Negative 8 plus positive 8 will cancel. And I'm left with 3x is equal to 10. And now I have multiplication. I undo multiplication with division. So I'm going to divide both sides by 3. My 3's will cancel out on the left-hand side and leave me with x is equal to 10/3. And one of the nice things about algebra is it is acceptable to leave a solution as an improper fraction, because you never know if you're going to need it again for another step. So you want it to be in the form you're going to use it moving forward.